This is a very important slide for this unit. What we're looking at in the middle is an illustration of all the important steps involved in synaptic activity. None of this is new, but we'll go over it one step at a time. It's important that you really understand this before you try to cover the mechanisms of drug action. So let's go through what I'll call the A through Z's of synaptic activity. Now, we begin by producing a neurotransmitter. Well, neurotransmitters are produced from precursor chemicals. Precursors are simpler molecules, or sometimes more complex and that have to be converted. But anyway, they're precursor, predecessor, they're the ancestor, if you will. I'm not sure how else to describe it, of the neurotransmitter molecule. And the precursor has to be converted into a neurotransmitter by use of an enzyme. Let's call this step A. Next, neurotransmitters, in order to be released, have to be packaged into synaptic vesicles. So the packaging of the vesicle we can call stage B. Now, when an action potential occurs, we release synaptic vesicles, and these vesicles have to now be transported to the membrane, and that transportation we can call stage C. Then the synaptic vesicle has to bind with the membrane and release its neurotransmitter payload, called that stage D. Then neurotransmitter has to go and bind with the receptor. Let's call the binding with the receptor stage E. What's left? Well, we have to clean up after ourselves. We have two mechanisms for that. This is illustrating reuptake. This is illustrating enzymatic deactivation, where acetylcholine is broken down by acetylcholinesterase into choline and acetate. Because remember, once you break down neurotransmitter, it's no longer neurotransmitter and it's therefore inactivated. Let's call this G. The final piece was the autoreceptor. Autoreceptors, if you remember, were on the presynaptic membrane, and their job is to monitor the cleft for the presence of neurotransmitter. And the more neurotransmitter the autoreceptors detect, the stronger stop signal they send for further neurotransmitter release. Again, they send a stop signal saying, stop releasing. We have enough. And we'll call this H. So again, let's go over it quickly. We begin with precursors that have to be converted into neurotransmitters. Those neurotransmitters have to be packaged into vesicles. Those vesicles have to move to the membrane. They have to release neurotransmitter. Neurotransmitters have to bind with receptors. After that point, we reuptake or degrade. Finally, let's not forget the autoreceptors that probe the cleft to see how much neurotransmitter is in there. And it tells the presynaptic neuron, stop releasing. We have enough. Make sure you understand this before moving on to the next video, because you're not going to be able to understand the mechanisms very easily if you don't know the basic machinery. All right.